Hello everyone. In the previous session, we have discussed about different basic elementary signals of discrete time signal. Here we will discuss about what are the different mathematical operations which can be performed on a discrete time signal. So basically, this is probably the most important topic of discrete time signal. So until and unless we will not study the operations on discrete time signal, it will be very difficult to understand the concept of convolution, the concept of Z transform, the concept of Fourier transform, and other kind of transforms. So probably this is the most important topic of signals and system, or you can say the signal processing. So the first operation is signal addition. So basically in signal addition, we will perform the addition of discrete time signals. Then we will discuss about signal multiplication, where we multiply two or more signals. After that, we will discuss about amplitude scaling or scalar multiplication. Then we will discuss about time shifting operation, which is divided into two types, time advance and time delay operation. Then we will discuss about time scaling operation, where we will discuss about downsampling, which is also called as decimation operation, and upsampling, that is called as interpolation operation. After that, we will discuss about folding operation of a discrete time signal, and after that we will discuss about folding plus shifting operation. So these are the operations, different operations on a discrete time signals that we are going to discuss today in this session. So the first operation is signal addition. The addition of two discrete time signal is performed on a sample by sample basis. I'll tell you what exactly a sample by sample basis. The sum of two discrete time signals, let us say the first signal is x1n and the second signal is x2n, is a signal y of n, say, whose value at any instant is equal to the sum of the samples of these two signals at that instant. So here one example is given. Perform the addition of two discrete time signals shown below. The first signal is x1n, which is 1, 2, -1, 3, 4, and the arrow mark is under the sample -1. So we can say this particular sample is the sample at origin. So this is my first finite duration sequence. The second finite duration sequence is x2n, which is 3, 1, 2, 5, 2. And the arrow mark is under the last sample. So I can say this is the sample at origin. Okay. So these are the two discrete time signals, finite duration discrete time signals, and I have to perform the signal addition operation. So what I'll do is that I'll first write down the first sample 1, 2, -1, 3, 4, and I'll arrange the second sample in such a way that the sample at origin of second signal must coincide with the sample at origin of first signal. Okay. So I have arranged these two signals in this manner. So as you can see, the sample at origin of first signal is -1 and the sample at origin of the second signal is 2, and they are coinciding in the same line. So after this arrangement, we will perform the addition sample by sample basis. So basically, as you can see, the first sample of the second signal coincide with no sample of the first signal. That means we have 0 sample at this place in this particular axis. Okay, so 3 will be added with the 0. In the same way, the second sample of second signal is 1 and it will coincide with 0 value. So 1 plus 0 is again 1. So the first sample of the addition is 3, the second one is 1. Next is the 2 is coincide with 1, so 2 plus 1 is 3. 5 will coincide with 2, 5 plus 2 is 7. 2 will coincide with -1 as it is the sample at origin. So 2 minus 1 is 1. 3 coincides with the 0 sample of the second signal. So 3 plus 0 is 3. 4 plus 0 is 4. And I'll put an arrow mark at this particular point, or you can say at this particular sample. So this is my resulting signal, the addition of the two discrete time signal x1n and x2n. So in this way we can perform the signal addition. So depending on the question, whether it is given 2 signals, 3 signals, or more than 3 signals, we have to perform the addition. Now this particular block is called the summation block. We can see These two signals are the incoming signals. The first signal is x1n, the second signal is x2n, and the addition result can be represented with the outgoing arrow mark, which is y of n. So this is my outgoing signal. So the next mathematical operation on discrete time signal is signal multiplication. The multiplication of two discrete time signal is performed on the sample by sample basis, as we discussed in signal addition. The product of two signals, let us say the signals are x1n and x2n, is a signal y of n, whose value at any instant is equal to the product of the samples of the two signals at that particular instant. The product is also called as modulation. So this is a very important point. Product operation is also called as modulation operation. Let us take one example. Perform the multiplication of two discrete time signal as shown below. The first signal is x1n, the second signal is x2n. I have taken the same set of samples which I have used in signal additions. So 1, 2, minus 1, 3 and 4. Second signal is 3, 1, 2, 5 and 2. Arrow mark of the first sample is at minus 1. Arrow mark in the second signal is at 2. So I'll arrange the signals in this manner. The first signal is written here, 1, 2, minus 1, 3, 4. The second signal is placed over here in such a way that the sample at origin must coincide with each other. Now, this 3 will be multiplied with the 0 of the first signal. 1 will be multiplied with the 0 of the first signal. So the result are 0 and 0. 2 of the second signal will multiply with the 1 of the first signal. So 2 into 1 is 2. 5 into 2 is 10. 2 into minus 1 is minus 2. Now 3 will multiply with 0. 4 will be multiplied with 0 and the result is 0, 0. So finally I can get this result y of n equal to 2, 10, minus 2. The arrow mark will be at minus 2. Now this particular block is used for the multiplication block. This is my first signal x1n, this is my second signal x2n, represented with the incoming lines, incoming arrow mark. This is my outgoing arrow, which is y of n, 2, 10 and minus 2. Now after the two operations, signal addition and signal multiplication, the next operation is amplitude scaling or scalar multiplication. So basically, in this particular operation, we multiply a scalar quantity with the amplitude. So amplitude scaling of a discrete time signal by a constant A is accomplished by multiplying the value of every samples by the constant A. This is the representation of scalar multiplication. We can use either of the representation. We can use the first representation, we can also use the second one. So x of n is the input signal. The scalar is A. After multiplication of the scalar quantity, the output will be A times of x of n. This is my x of n, this is scalar A, this is my output A dot x of n. So let us take an example. X of n is equal to 2, 1, 3, minus 2, 1. The arrow mark is under the sample 3. Now if I need to determine A times of x of n, then this particular scalar quantity A will be multiplied with each and every samples of this particular signal. So the resulting signal will be 2a, 1a, 3a, 2, minus 2a, 1a after amplitude scaling. And the arrow mark will be put over here. So this is one example. For the signal shown below, determine 2 times of x of n. So the signal is given as x of n equal to 2, 1, 3, minus 2 and 1. The arrow mark is under the sample 3. So the scalar quantity is 2. 2 is multiplied with x of n and the result is 2 times of x of n. Now 2 is multiplied with this amplitude x of n. So 2 into 2, 1 into 2, 3 into 2, minus 2 into 2, 1 into 2. And the resulting sequence is 2 times of x of n, which is 4, 2, 6, minus 2, 2. So you can see here, if the scalar quantity is greater than 1, then the length of the amplitude will increase. And if the scalar quantity is less than 1, then the length of the amplitude will decrease. And if the scalar quantity is positive, then amplitude will be in positive y-axis. depending on the samples. So here I have included one assignment question depending on the discussion.